Welcome to Surge Suppression Incorporated's Modular Training Webinar Program. This is our Knowledge is Power series. Today we will be discussing current loop surge protective devices. Current loop surge protective devices, SPDs, are used throughout industrial, manufacturing, and commercial facilities. The need to measure speed, volume, weight, flow, or any number of other variables make the current loop a vital part of many operations. Protecting the current loop circuit and the equipment at both ends of the current loop is the job of the current loop SPD. The vast majority of current loops in use today are 24-volt DC. The loop runs from the power supply to the sensor, where the current is adjusted between 4 and 20 milliamps. It then flows to the DCS, or Digital Control System, which converts the 4 to 20 milliamp current level to the corresponding level on the scale. The HART Digital Data System is a low-frequency signal that rides on the 4 to 20 milliamp loop along with the varying current. They are used for digital readouts, status, computer management, etc. Our standard current loop products will not interfere with the signal. A truck scale offers a good example of a current loop system. As the weight on the truck scale increases, the stress on the scale load cell increases. This increases the resistance, which increases the current. This change in current, although very small, is read by the monitoring equipment at the other end of the current loop. Once calibrated properly, the truck scale can be a very accurate method for determining the before load and after load weight of any truck. By subtracting the before weight from the after load weight, the actual weight of the cargo added is determined. The top left image is a low-profile scale. On the right is a raised bridge scale. On the lower left is a multi-platform scale. There are three sections: the steering area section to measure the weight on the front axle load, the drive axle section to measure the weight on the drive axles, and the trailer area section to measure the weight on the trailer axles. The truck scale uses load cells at various points on the scale bed to measure the weight of the truck. Each load cell, or weigh bar, is attached to the scale bed and to the stationary base plates. As the scale bed moves down under load, the stress on the load cell increases, increasing the current on the current loop. In this image, we can clearly see the load cells on the side of the scale bed and the accumulator box. The leads from each load cell go to the accumulator box, where they are combined and then transmitted to the scale house to be converted to a weight reading on the scale equipment. The number and types of uses for current loop systems is almost unlimited, but they are often ignored when the facility is considering surge protection. The sensors at the far end of the current loop are usually considered too inexpensive to protect with an SPD. If there is anything there at all, the monitoring equipment usually comes with a sacrificial, very basic SPD that is more of a one-and-done type device. Until the end user suffers a catastrophic failure during a critical use period, the end user believes they are adequately covered. A concrete plant has several opportunities for use of a current loop SPD. The truck scale is used to weigh the concrete revolving drum truck before loading. The hoppers at the top of the loading area are each loaded with cement or aggregate. As the hoppers are loaded, the increase in weight of each is monitored by the load cells and transferred by the current loop circuits to the control house, where the operator can stop the loading conveyors when the desired amount of cement or aggregate is in the hoppers. As the loads of cement and aggregate are transferred into the concrete truck revolving drum, water is added and monitored with a flow meter on the water line. Once loaded, the truck scale is used to measure the increase in weight due to the load. When the proper amount of cement, aggregate, and water is loaded and the mixing drum is rotating, the concrete is mixed during the drive to the construction site and ready for delivery upon arrival. All of the weights and flows are critical to achieving the proper mixture of cement, aggregate, and water for the desired strength rating for the concrete and for the proper accounting and billing for the concrete delivered. Current loops can be 2-wire plus ground or 3-wire plus ground. They can also be with or without a shield on the cable. Take the time to get the necessary information to determine the proper SPD for the circuit. Specifying the wrong type of current loop SPD could mean not being able to install the SPD in the available space or the type of environmental conditions, as well as not working properly on the circuit and corrupting the information. This current loop SPD is the most common type. It is used to protect a 2-wire current loop. The positive and negative wires are landed on the input terminals, and the positive and negative wires going to the protected equipment are landed on the output terminals. The number 10 AWG ground cable is attached to the ground lug on the SPD and to the common ground bus or other connection point for the single-point ground source. Never create a secondary ground system for the current loop SPDs. Unless correctly bonded in the earth with the main service entrance grounding electrode, the difference in potential will create a ground loop with possible substantial current flow on the current loop circuit to try to equalize the difference in potential between the two ground sources. This can result in damage to the SPDs as well as the monitoring equipment and other equipment on the electrical system. In this installation, the 2 wires of the current loop are entering the cabinet from the bottom and connect to the input side at the bottom of the current loop SPD. The current loop circuit wires exit from the top terminals of the SPD and go to the protected circuit board at the top of the cabinet. The ground wire on the current loop SPD attaches to the central ground point on the cabinet. This is a Kelvin-connected current loop SPD. It can be used in the same installation as the previous SPD. In this case, the positive and negative wires of the current loop circuit are each looped to their respective terminals on the SPD and then continue from those terminals to the protected equipment. This creates a parallel connection to the SPD on the circuit with virtually no lead length. And where the standard 2-terminal set of the previous SPD has 5 ohms series resistance per wire, 10 ohms per loop, the Kelvin-connected current loop SPD has 0 ohms series resistance. For sensitive applications that cannot or do not want to recalibrate the current loop after installing the SPD, the Kelvin-connected current loop SPD can provide the needed protection without the resistance. This SPD has 3 terminals in and out and installs in the same manner as the first standard current loop SPD. The only difference is that the current loop circuit includes a shield wire. The shield wire is attached to the 3rd terminal at the monitoring equipment end of the current loop circuit. If a current loop SPD is also applied at the sensor end of the current loop circuit to protect the sensor assembly, the shield wire is left disconnected from the SPD at the sensor assembly end of the current loop circuit, commonly called floating the shield wire. This avoids creating a grounding path between the monitoring equipment and the sensor assembly if there is a difference in ground potential between the equipment at both ends of the circuit, and helps to ensure that any difference is addressed solely by the power ground that goes back to the main service entrance single-point ground source. This current loop SPD is in a more compact enclosure with removable terminal strips and is DIN rail mountable for ease of installation and space saving inside a cabinet. It is designed to protect from 1 to 3 pair current loop circuits with no shield. This installation image shows 2 of the current loop SPDs installed on a DIN rail inside a control cabinet, with the circuit wires attached to the input terminals at the bottom of the SPDs and the circuit wires going to the protected equipment inside the cabinet attaching to the output terminals at the top of the SPD. The ground wire is also attached to the ground lug on the top of the SPD, with the other end of the grounding cable attaching to the cabinet central ground point and from there to the main service entrance single-point ground source. This current loop SPD can be mounted to a DIN rail in a cabinet and can protect from 1 to 3 pair circuits plus a common shield terminal. With multiple shielded current loop circuits, it is a compact and economical method for providing necessary surge protection. These current loop SPDs are designed for installation within conduits in chemical or corrosive environments. They are made from 316 stainless steel and can be installed directly in line with the conduit containing the current loop circuit wires. There are 2 models. The first is the in-line with the positive and negative wires of the incoming current loop circuit plus a ground lead on the input side from the exposed current loop, and the positive and negative wires of the current loop circuit on the output side going to the protected equipment, monitor, or sensor assembly. The second model is the SPD with a cap on one end and both sets of input and output wires plus the ground lead extending from the uncapped end. This model is designed to be attached to the conduit through a T-fitting or junction box, allowing for easier access for replacement if it ever became necessary. This is a standard conduit SPD with the current loop circuit entering from the left, going through the SPD and into the junction box. The current loop circuit exits out the back of the junction box and up the wall. These are similar to the previous SPDs but are 3-wire plus ground current loop units. This is a capped current loop SPD installed on a sensor. The connections are internal within the sensor. This is used where the end user does not want or does not have the ability to put the current loop SPD in line in the conduit running from the sensor to the DCS. In this instance, the sensor already had an available fitting to connect the capped current loop SPD. Where space on a DIN rail is limited, this 1-pair or 2-pair current loop can allow you to specify a current loop SPD in a space where a standard DIN rail current loop SPD will not fit. There are 8 terminals on the detachable terminal strip, 4 incoming and 4 outgoing. This SPD has a maximum continuous operating amperage of 500 milliamps. This is the same as the previous unit with the exception that it is limited to 1 pair in and out and a shield. This takes 5 terminals, 2 for current loop circuit in, 2 for current loop circuit out, and 1 for the shield. This SPD also has an MCOA of 500 milliamps. The next 2 compact DIN rail mountable SPDs are the same as the previous 2, with the exception that they are rated for a maximum of 5 amps MCOA. This makes them more robust and more suitable for harsh environments. This current loop device is limited to 1 2-wire circuit plus a shield and also has a 5 amp MCOA for a more robust SPD for harsher environments. If you want to measure volume, flow, speed, pressure, level, weight, or any other variable where a sensor can detect a change within a known range, a current loop is most likely part of that process. A current loop surge protected